Diffraction of light at straight edge. To determine wavelength of monochromatic source of light by obtaining diffraction at straight edge. For that, optical bench, straight edge and sodium lamp. Since in its title the word diffraction is there, just we have completed one practical on diffraction of plane diffraction grading. RP of plane diffraction grading. In that I have explained the diffraction. One of the basic optical phenomenon, that is diffraction of light, whenever, because the basic or the rectilinear property of light is nothing but light always travels in straight line in a same medium, is the rectilinear propagation of light. While we are studying the phenomenon as diffraction, there is a obstacle between source and the screen, because the light starts from source and reaches at the particular screen. If there is no any obstacle in between source and the screen, then it follows its rectilinear propagation of light property. But if there is an obstacle in between source and the screen, then the light follows the phenomenon of light is known as diffraction. Now here we are using the optical bench as an instrument in the dark room for studying this diffraction phenomenon. Now what is the obstacle we used here for the diffraction? The obstacle used here for the diffraction as straight edge. It is the source of light and it is a screen. In order to have this diffraction pattern on the screen, it is a obstacle as a straight edge. Now what is the actual physical object we are using as a straight edge obstacle? And that physical object is nothing but the well-known razor blade, because the razor blade is having two sharp edges, and that is why we are using here in between the source, in between the path of the light from source to screen, we are using here a obstacle as straight edge. Now, according to rectilinear propagation of light, light always travels from source to screen. It is shown by this dark ray here. And when there is an obstacle in between these two, then the light bends. As the definition of diffraction, the light bends and it is showing from S to S dash, this source to again S dash, to this side and so on. Now, what is the resultant diffraction pattern obtained here? It is shown in this 1, 2, 3, 4. These are the upper peaks, and these 1, 2, 3. These are the lower peaks. In all, in this optical theory, we are calling these upper as maxima and lower as minima. Means there are successive maxima and successive minima actually observed or obtained as an image pattern. And while we are focusing those to towards the telescope of the instrument, then it shows like this, that is alternate dark and bright vertical bands are there. These are the resultant images of the experiment. Now, if first observed band is mth band, the next two is nth band, then we have to find the difference of xn minus xm equal to k times square root of root n minus root m, and hence we have to find out this k by the formula xn minus xm upon root n minus root m. And here finally k is observed. Therefore, these are the xn micrometer reading for nth dark band, xm micrometer reading for mth dark band, n order of the nth dark band, m order of mth dark band, p distance between the straight edge and that of the eyepiece, q distance between the straight edge and that of the slit. And now least count of micrometer of the optical bench is 0.0005 centimeter. It is again a different method you have to adopt for the calculation of least count of the optical bench. It is an versatile instrument used for the optical study of optical phenomenon. Now bench error, distance between the straight edge and the eyepiece, then distance between straight edge and the slit we have to calculate here. Now, what do you mean by bench error? As like in case of vernier caliper and micrometer screw gauge, we have to find out there the error, or maybe we can call it as instrumental error. On the same line, we are calculating here bench error in case of this optical bench. It is a big instrument in the dark room we have kept there. Now it is our observation table. Order of the band n, its a square root, then micrometer readings for those, then their difference and the value of k. If m equal to 1, then xm equal to this. For n equal to 2, xn. Again for m equal to 3, xm, and n equal to 2, 4, it is xm. And after the calculation, we are coming to be this the value of wavelength of monochromatic light by the experiment as by calculation 5952 angstrom, and wavelength of monochromatic light by graph is 582178 angstrom. It is the graph of xn versus root n, square root of n. Both are the quantities taken from our above observation table. Xn is plotted on y-axis, root n is plotted on x-axis, and such type of resultant graph will be obtained there, and we have to find its slope as k, and while substituting there we are able to have such type of nice result of the wavelength of monochromatic light used in this particular experiment. Now regarding the oral questions, we should know what is monochromatic light. What do you mean by monochromatic light? Which light we are using, you are using here, which phenomenon you are using here, which type of obstacle is used here, and hence how you can manipulate or define or explain the title of the experiment, what type of resultant images are observed there, what this graph is called as. Actually this part of the graph or the images is called as intensity diagram. And it is the plot, actually the plot of intensity versus angle of diffraction theta, and its transformation is in this way while we are recording the reading. Actually it is happening there. The successive maxima and minima are obtained there. It is known as, this plot is nothing but vertical axis as intensity and horizontal axis as angle of diffraction, and therefore as the angle changes the fringes changes, and the resultant fringes for recording the readings were taken in this form. And completing the experiment, it is the total about diffraction of light at straight edge. Means for studying the phenomenon as diffraction of light we are using the obstacle. Different types of obstacles are there. In this experiment we are using the straight edge as an obstacle.